Read code question number 322, coin changes. This is medium question. Let's get into it. You are given coin of different denomination and a total number of money amount. Write a function to compute the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. Let's check with example 1. Coin is 1 to 5 and the amount is 11, so we need to get 1 5 and then 2 5. This is 10, so we needed 1, so we needed 3 coin. And then second, the coin is 2. There is no way to make the 3 with the coin 2, so return -1. How can I do? What should we do? And today I'm gonna use two approach. First is use the BFS, and then second is we're gonna use the DP. So the reason why I try to use BFS, and then because BFS is the one of a good approach to find minimum path or minimum length or minimum amount, because BFS, when the traverse BFS try to go into every step, every way it able to go. So first searching, second searching, it found something that is shortest path. Does this make sense? So we're gonna use BFS, and then to make it better performance, we also use the backtracking, and we did not go traverse if that is out of candidate. I will not go there. And okay, so let me implement that first. Okay, I will use this coin. First, I will import collection to use DQ, and like Q, use collection, DQ, and then I will put coins. So I will start all of coins in the queue. So Q now has 1 to 5, and then we need counter. Count is which one? 0 or 1? Which one? This is 1, because we already put in the queue means we start with using one queue, the one coin first. So I will make all of combinations, start with 1 and then start with 2 and then start with 5 works. Okay, and then one more, I use the BGT and then use the set. That means okay, let's say we make the amount is 5. There is several ways. First is use 5 1, and then use 1 and 2 2, and then use 5. So at this time we will traverse here first 5. So if I visited set, put the 5 first, and then next any combination amount is 5, I will skip, because this one cannot be candidate. The reason is we needed to find fewest number of coins. That's right, because we already this one just to use one coin, but this one is we use 5 coin, 3 coin. It cannot be the candidate best output. Does this make sense? So we will use BGT set as this region, and then for Q, okay, let's iterate and use file. Q is not empty, and then I will iterate only same amount of Q, because to use the count. So for in range length Q, and then after Q finish it, that is time to increase the Q. So first round I will only check this one, and the second round is the new one, new comes item into the queue. So get current is I will get 1 from queue, and I will check if current is amount, I will return count. And then before that, okay, let's make one edge case. Okay, if amount is 0, what this mean? This means if amount mean 0 is, what is return value? -1? No, return 0. Because amount 0 is we don't need to give back any coin. So that is not negative 1, just 0. Count, and then get next from the coins, and then make the combination next plus current. That means, okay, first current is 1, and then if next is 1 means actually we needed to add 1, so this is 2, and then next is 2 plus 1 is 3, and then next 5 1 is 6. So this is the next value, right? Start from 1. And then next is the part 2, and the same way, 3, 4, 7. And then in this case 5, 6, 7, 10. This is code for that. And then if next not in visited and next amount is small equal than amount, that is the two condition for candidate, and then queue append next, and then next round it also used here. Okay, makes sense. And then last, if we do not find any the amount, return -1. Okay, looks good. Oh, I forgot to visit. Sorry. Okay. Okay, not bad. Okay, now it's time to implement with the DP. So DP, I will use the DP table. It's the same amount of the number plus 1. Start with 0 and implement infinity, 5, 6, 7, 8, 9, 10, 11. And then let me use this example. So this one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Okay, and then I will use this coin first, and then start one coin, means this is the amount to use the coin. Actually the amount 1 is we can make 1 coin, right? And then first I will use only 1 coin, and then this one I also use the 2, right? 3, this makes sense. 4, each means, okay, let's make the DP relation. DP I is DP I minus coin. Does this make sense? Okay. Okay, let me do again. Now we start from the coin. Coin is here, right? And then at this time, DP is same as DPI 1 minus 1. Means we just refer the previous state. We did not use this coin. That means now is 1, and then 1 minus 1 is the state did not use here, right? So this is 0. So now this one must be 0, no 1. That means this one plus 1. So okay, rest 2. 2 is dp2 is dp minus coin is 1, right? 2 minus 1, 1, so this is 2. Same way, this is 3, 4, 5, 6, 7, 8, 9, 10. To compare with this one, we need it, okay, this one is the, never mind, I will explain later. So yes, this is makes sense. To make the 11 blocks with the one coin, 1 blocks, it need the 11, right? So this is makes sense. Now coin is 2, so it start with the 2 right here, and then at this time I is 2, coin is 2, is the here, indirectly here, right? This one state is the we do not use this coin, right? At this time is 0. It also makes sense. 0 amount is 0, right? And then if we use this one, and then this one, 0 plus 1 is 1. 3 also same, the 1, so this is 2, and 4, this is the 1 is 2, and then 3, 3, 4, 4, 5, 5, 6. Okay, let's check. To make the 11, we needed to 5, 2, and then 1, 1. So total is 6. That is makes sense, right? Awesome. Okay. Okay, now let's make the 5. 5 also. 5 is here, right? And then 5 is 0, so this is 1. And now it's 1, so this is 2, 7, 2, 8, 3, 9, 4, 3. 9 minus 5 is 4, right? This 2. 10, 5, 1 is 2. And then 11 is 6, so this is 3. So finally, we needed to out this one, right? And then, anyway, later, if some value is bigger than this one, the later value is, if the distance is 4, at this time we did not update it because it already has the optimal value. So our solution is dp I comma dp I plus 1. That is the equation, dp equation we're looking for. That is makes sense. Okay, and then let's implement this code. So first we needed to make a dp table, and there's the float is inf to save the smallest number, and this one is must be amount plus 1. 1 is for dp0, right? We needed to calculate it, and then dp0 must be 0, and then let's coin c in coins. Let's get 1 coin from there, and therefore in range from coin to amount, right? Plus 1 to include amount. And then let's use this dp operation, this equation, and then after made it, and then check if this one is still infinity, that means we could not make this value, right, with the coin, any coin. At that time we needed to return relative 1. So if dp I is infinity, at that time we needed to return minus 1. Otherwise we need to return dp minus 1. This is not I, right? The final. Okay, let's check the code. Oh, pick some typo. Sorry. This is a C, right? Coin C. Okay, looks good. In this case, time complexity is it uses the coins, and then each coins the amount to use the amount one. So time complexity is start from coins and then amount. I think it is if the amount is S, time complexity is S, and then space complexity also S. So I think this we can say the linear time with linear space. Thank you.